Hey, what's up guys? I know it's been a long time since I made part one of this video, but life just gets kind of crazy and you kind of lose grasp of, all your projects and I don't really have a lot of free time to do anything, but since I'm off work and I don't have a whole lot going on right now, I figured I'd continue with the series since I've got quite a few requests for it. So today we're going to be looking at memory and how memory works and how that's going to correlate into our game hacking adventures. So let's dive into some concepts. So first off, I'm assuming that you've done what I've said in the first part of this video in the series and learned a programming language. I recommended C++, but you can really choose any language since they'll pretty much all adapt fairly easily, as long as you're not trying to do this with like a super high level language, of course. Yeah, so let's dive into some memory concepts here. So first off, we're going to take a look at dynamic and static memory allocation. Now, I'm going to start off by going into some technical details, but don't worry, it'll all make sense either when I go through like examples later in the video, or in the next video when we're actually doing some hands-on with actual memory editing. So if this doesn't make a lot of sense to you right now, don't worry, it should all come together. So dynamic memory allocation is when we tell our program to store some data and we're not really concerned where the memory is going to be stored. So it then locates a block of free memory that is the correct size that we requested and stores our memory there, just based on what's available in memory. So like I said earlier, the exact location of the memory isn't known in advance. It's allocated at runtime of the program. Now, this is really important, and this is why we actually care about dynamic versus static memory allocation. So now let's take a look at static memory allocation. I'm going to be using the terms DMA for dynamic memory allocation and SMA for static memory allocation. So if I use those terms, just remember that's what I'm referring to. So unlike DMA, SMA is allocated at compile time, meaning the address is assigned, is predetermined at the time that we compile the program, so the address is known. As hackers, static memory addresses is something that we like. It saves a lot of time, but unfortunately most games don't just have all their values assigned to static memory just sitting there. It usually takes a little bit more work than that, and that's where pointers come into play. But before we dive into pointers, I want to show you guys an actual example of DMA and SMA, just to confirm that you understand the difference and the importance of understanding the difference of the two. So I'm going to go ahead and open up my Visual Studios here, and here we just see some basic code that is creating an integer named health and a static integer named ammo, and then we're just outputting the addresses right here. It's pretty straightforward code. So this is just the code. I'm going to actually run the program here. So I drag it over here. So here we get the addresses of these two integers that we've assigned. So we're going to write these down real quick so we don't forget these. So 0025F, whoops, 0025F74801229000. That was too many zeros, right? Yeah, okay. So we're going to close it out, and now we're going to open it back up again. I'll drag it back over here. As you can see, the health address has changed, but the ammo address has remained the same. This is runtime versus compile time difference like we were talking about. As you can see, because ammo is static, the address is determined when we compiled the program, so it's not going to change. However, the integer is determined at runtime, so each time we run the program, the address is going to change, which is really important when we start working with memory and trying to edit memory addresses. We don't want to edit memory addresses that aren't there, so we need to be careful of that. So now that we've got that concept down, we're going to kind of complicate things a little bit more. It's not like it doesn't get really complicated, it just kind of adds a layer of confusion for people that are new to it, and that's pointers. So pointers are they're basically what they're called. They point to another address in memory. So pointers are generally used for constructing references, and those are in turn used to create data structures, and data structures are going to play a big part in hacking a lot of games, because data structs can hold big blocks of addresses and values that can save us as hackers tons of time. Oftentimes, in order to find all the information about a character, weapons, maps, you name it. Oftentimes, if you find one value, you can then you can dissect its data structure, and you'll find all the information and addresses of every other value, or a lot of the values contained within it. So it can really be a big advantage to actually understand how pointers relate to data structures. It can really save you a lot of time. Instead of going and finding every address individually, you can find one and then look in the structure and see what else you can find within the structure. So pointers are going to play a big part in your game hacking adventure experience, whatever you want to call it. But we don't really need to go into too much detail about it until we have a visual representation in the next video, since I feel like it might just be more confusing than it is helpful to go into more detail about that without actually having a visual representation. So yeah, that's going to wrap it up for this episode. Thanks for watching, guys, and thanks for your continual support. You guys really have no idea how much it means to me having you guys like my videos and leave feedback, even if it's constructive criticism is always accepted. I'm always trying to improve, so thank you so much for the support, and the next video in this series will be coming out soon. I promise it won't be as long as the gap between 1 and 2. I'm gonna try and do it weekly, and more if I possibly can, until there's enough content to stimulate, obviously, because I don't want to produce too much content that you can't even catch up. So I'm gonna try and do it balanced, but definitely more than the gap between my first and now. So yeah, thanks for watching, guys, and see you in the next video.